Okay, so we are waiting for the biweekly, and just 1 hour ago, I was done with at coder contest also. So let's go. That one went pretty well, and let's see. I have some hopes with this one too. So uh, yeah, we'll try to solve all of the problems. I think that's the bar that I have set for myself. Okay, Joe, what? Where are the problems? Okay, so minimum sensors to cover grid. Okay, this is going to be a grid problem. Uh, some loading time. Well, a lot of loading time. Okay, you are given n cross m grid and integer k. A sensor placed on RC covers all cells whose distance from whatever this is at most k. What is the distance? Is max of okay the max of both differences. Your task is to return the minimum of sensors required to cover every cell of the grid. Okay. Mm, at most k. Fine. So basically, if it is at most k, then it would be covering everything up to k here. Here, isn't that a square of size k, right? So mm, n cross m k is equal to 1. So then you will need 4 sensors. Okay. N is equal to 2, k is equal to 2. So the grid of size 2. See, if you put a sensor at some place, I think we can go mm, one sensor can uh, take up to mm, k in both direction, right? So it can take up to 2 rows, right? So you will need 3 sensors here, and here it can take. Uh, so yeah, uh, can I actually try to place those sensors? Why not? No, I don't think so. That would be a good way. Well, uh, first question is medium itself. Mm, the given integer enums a pair of indices ij is called perfect if the following conditions are satisfied. I is less than j. Okay, a is equal to nums I, b is equal to nums j. Then of uh, minimum of their difference, minimum of their plus and minus whatever is minimum is less than equal to minimum of this. Maximum is greater than. Mm, let's think about the first one only right now. Okay, so today I think it's well, we have a lot of submissions on this one already. See if this covers. So see if I place one here. No, you don't need to place one here. You can start from the. Uh, so one will cover 2k plus 1 rows, right? I think that's it. It will cover 2k plus 1 rows. So that means 3 rows, right? And 3 rows it will cover. And here, so 2 will work, right? And here, how many you will need? Uh, well, into that, I guess, right? So we can try that. So int y is equal to 2k plus 1. Uh, int a is equal to max. Uh, mm, See, it would be n plus y minus 1 divided by y. Int b is equal to n plus. I'm just trying something here, right? 4. Maybe it works. I have literally no idea. It does. Okay, cool. You're given an integer array nums. A pair of indices ij is called perfect if the following conditions are satisfied. Okay. So, I mean, think about it. Wait, what are the constraints? 10 to the power 5. Quadratic won't work, of course. So, this should hold. So, can I somehow find for some index that I need to translate into something intuitive. So let's say I have a number 3, right? So if the other number is I mean, you will have negative numbers, right? So minimum of their magnitude, right? Okay, and one would see, let's say minus 3 minus 4. So one would give me sum of their magnitude, right? And in this case, uh, one would give me sum of their magnitude and one will give me the subtraction of their magnitude, right? That's it. So if I have some 4, so basically the minimum of this, right? So if I have smaller number than this, right? 3 2 1, so minimum of this, right? Their difference, uh like here of course sum of magnitude, and there would be so of course always this. Okay, so basically the difference of their magnitude, right? So the difference of their magnitude, right? And so difference of their magnitude should be less than equal. See, difference of their magnitude should be less than equal to uh, uh, smaller magnitude, right? Whichever smaller magnitude is. And uh, sum of their magnitude should be greater than equal to uh, bigger magnitude. Okay, so first of all, we can treat the whole array as positive values. Then what I can do is that uh, I need to store basically what I need to store with this. So what we are saying is that the difference so is small for a smaller value, of course. This difference for smaller value, let's say it's x, right? So x should be great no x should be greater than equal to, let's say, whatever my current value is, current minus x, right? So basically current should be less than equal to 2x, right? What does that mean? X should be uh, greater than equal to current divided by 2. So all values that are this, they will pass. Second case is sum of their magnitude. So current plus x should be greater than equal to current, right? That's it. Yep. Is that it? No, for so a smaller value we are talking about, right? uh, Wait, we have car, we have x, and first of all x is smaller, right? So car minus x should be their difference. Okay, in both, in this case it will be difference. It should be smaller than equal to x. So that basically means that x should be greater than equal to cur divided by 2, right? And x should be less than equal to cur. Cool. Second thing would be here that cur plus x should be greater than equal to cur. So what does that mean? Uh, that just basically means that the magnitude should be greater than equal to 0. That's always true. Okay, that's always true, right? Now cur is actually greater than x. Okay, so for first case, basically you will have x minus cur, what, x minus cur, the minimum, right? X minus cur, well, just check for smaller. Why do you actually you don't need to check for bigger, right? Yeah, you don't need to check for bigger. That would do. That would do by itself. So define ll long, and what we can just say is that uh, we can sort them, right? It doesn't matter. Yep. So let's just say for auto and x a is equal to abs a. Now sort, oh come on, a dot begin, a dot end. Cool. Now what I can say, I need to find two values. Those are how many values are, mm, let's put it in a set. No, not in a set, maybe in a vector. That would do the job. So vector int v, right? And then I will go for auto and x a, right? Now at the end I will v dot push back x, right? Uh, if v dot size is equal to 0, does not equal to 0, then you do this. Cool. Okay, so I have sorted them, so all of them must be smaller. Well, I can check that by binary search. Yep. So why not just go like that? Yeah. For int I is equal to 0, I less than I plus plus int I want the so what could be the possible range? 0 int r is equal to I minus 1 while l less than equal to r. Okay, start from 1. Okay, while l less than equal to r. So what was my hypothesis from me? What was my deduction? It was that x should be greater than equal to cur divided by 2, right? So int m would be l plus r divided by 1. Yep. And total answer is gonna be l less equal to 0. Uh, Now what basically we can say here is that we need all of the values that are greater than equal to cur divided by 2. So what does this basically means is, this is for 13, it should be 7, right? So it's plus 1 divided by 2 in that sense. So see, so if basically am is greater than equal to uh, what, ai plus 1 divided by 2, if it is greater than that, then what I can do, if it is greater, then basically j would be at I right now, so we don't add anything now. So then what I can basically say that j can move to m and check for better indexes. So r is equal to m minus 1, check for better indexes. Otherwise else I have to go L m plus 1. Cool. That's it. And then rest plus equals LL max of 0 LL, 0 and uh, I minus j, I guess, right? And then I can just say return res. Let's see. So there's no function. Okay, this should be called on X. We don't need this vector. Let me define it because 2 fine. Give me 4. 4. Yep. Give me 0. 0. Yep. I'm not going to take a risk and change everything to LL. Yep. Yeah. So it was 0, 4, 2, right? So 0, 4, 2. Let's see. Accepted. Cool. Now let's go for the third problem. So minimum cost path with edge reversals. You're given a directed weighted graph with you're given a directed weighted graph. Okay, at n nodes leveled from 0 to n minus 1 and in array edges. Okay, yeah, cool. Every node UI has a switch that can be used at most once. When you arrive at UI and have not yet used its switch, you may activate it. You may activate it on one of its. Wait, every UI has a switch that can be used once. When you okay, you may activate it on one of its incoming edges, VI to UI. Reverse that edge to UI to VI and immediately traverse it. Cool. This reversion is only valid for that single move and using a reverse edge cost 2 into WI. Return the minimum total cost to travel from 0 to n minus 1. I think I can smell state dice straw somehow. So, yep, quadratic is not gonna work here. And so, I mean, let me think about it. If state dice straw would work here, what would be my state? See, first of all, the thing is that the graph would be something like this. Yep. So let's say I go. What basically it means is that and like this. So now what I can do, I can come from some edge here, and then maybe I can go back here, which of course I won't do. But for some incoming edge, I can turn it back. Cool. So if I know the minimum distance to this point, uh, see, use part 0 to 1. Okay. I got it. So is it not just dice straw? Like basically, see, I will come to each node without reversing its own incoming edge. No, I will come. So if I come from this edge, well, I can reverse this edge. It doesn't matter. So let me reverse it. Let me reverse all of them. What's the issue? So let's say I reverse all of them and then I have a good distance for this one. And in dice straw, we actually never revisit some node. So dice straw should work here. Basically, whenever you come to a node, you actually just uh, take it that way. Maybe I don't know. Maybe I'm gonna try. So is it let me first make a graph here. So vector and ADJ and plus one. Let's go with this only. I think it will work. Auto and V edges. So int x is equal to v0 y. It's a directed graph, right? Yeah. So now what we can say, x would be a pair. Yep. So ADJ x dot push back YW. Yep. Let's push that. Cool. That's my graph. Now we can run a dice roll on this. Think about it. So 0 to n minus 1 return. Yep. So let's our prefer LL. Uh, long dist n INF would be 118 and dist 0 should be 0. And whenever you come to a node, well, so just have in set, what do we need? We need just the distance. Yep. So let's call it pair intent. In set st. First of all, you will have dist, and then you have node. So st dot insert 0 0. Cool. But wait, there's an issue. So let's say uh, it was reachable from here using let's say this is 30 and this is uh, 65 already. Okay. So whichever nodes, can its distance be no? Because if you come at node, everything comes that will have a worse distance in this. Well, mm, I don't know. Maybe. I mean, let's try. Maybe I don't know. I don't know. It's not going to take that much time to implement, anyways. So while st dot size uh, auto du would be st dot again, and then I would say st dot erase du. Yep. And then what basically we can say is that for each node, for auto and incoming and okay, so there should be RADG also. And here in RADG we will push in YX, right? So for auto and V from ADJ U, if dist V is actually greater than D plus, okay, if it is greater than D plus W, then uh, uh, what do? We actually do st dot erase this VV, right? And this V is equal to D plus W, and then again push it. Cool. Same thing we will be doing for RADJ, but this time the condition would be 2 into W. So then we will make it that. Yep. I think that's it. While st dot size, there isn't much to say. But now I can say return dist n minus 1 if it is the max distance, what will be the max distance? It can't be more than 1e15. So if it is that, if it is more than that, 1e15, then we can go for -1. Otherwise, just -1. Cool. That's not it. Redefinition where? That's already checked. Yeah. Mm, what's the answer? First case, it's okay. We give -1. Cool. Second one is 3, but -1. Fine. Why? Uh, xy. Okay. 1, 2. Common mistake. -1. -1. So xyw is good. X to x we push yw, to y we push xw. Distance of 0, 0. Can push 0, 0. We take begin. Yeah. S0 is du for v adju. If this is greater, then okay. Second time it would be insert. Yep. Come on. 3. That's less. 3 again. But first case, why would you give a 3? Let me think about it. So we started at 0, and we went for relaxing these edges. So these two will become 2 and uh, 3. So this now 3 will become 6. Cool. And here this one will become 3. Then 3 plus 2 should be 5. Why is it not 5? Well, this is 3, right? This 3. Oh, this is fine. This should not be a problem. Whatever this. What? I mean, that shift was. Wait, why this that shift didn't work? I don't know. Left shift is multiply by 2, right? So 5 and 3. 5 and 3, I'm gonna take the gamble, but I'm gonna replace every int with ll, because I don't want to take uh, I mean, runtime errors, overflow errors for this. 5, 3, submit, come on, work. Accepted, cool. So yeah, I think it was easy. Maybe I overthought it. Could have done a bit earlier. So yeah, I'm good rank. Now let's go for the fourth one. We have ample time, so I'm looking forward to it. Minimum cost path with teleportation. You are given a m cross n 2D integer array grid and an integer k. You start at top cell this, and the goal to reach is the bottom cell. Cool. There are two types of moves available. Normal move, you can move right or down, okay, from your current cell. That is this or that. The cost of this is the value of destination cell. Teleportation, you can teleport from ij to cell xy such that grid xy is less than equal to ij. The cost of this move is 0. You may teleport at most k times. Return the minimum total cost to reach this cell. What are constraints? M and 80 K10. This is screaming some kind of DP to me. State, like basically for each uh, we can have m, we can have I, j, and like how many time I have teleported, and what is the minimum cost this requires. Cool. Now, so basically for this you can come from the previous cell, of course, right? You can always come from the previous cell, but but teleportation is a bit different. But see, if you can teleport to the last index, you would do it, right? And so, but the thing is that for I, j, the calculation should be in this manner, right? In increasing order of I and j. But for this teleportation thing, the calculation should be in the order of what do you say, value, right? So because basically teleportation needs to know what is the minimum answer for. Well, we can go with in increasing order of teleportation. So teleportation does not change maybe. K teleportation you can only come from. So you can go in increasing order of teleportation outside the loop, right? And inside the loop you can go with aij. So for 0 you would know, like with 0 teleportation how can you come at this place, and then with 1 you would know. What are the number of states we are looking at? K is 10, ij is 80 into 80, and I think I'm looking at another 80 into 80. So that makes me uh, what? Workable. So what I'm missing here? If this is it, I don't think so. I'm missing anything. Maybe this is just easier. Um, I'm thinking about implementing it, to be honest, because yep. So let's call it V. Yep. And wait, but there's another thing that for 4, I would like to get done with. See, teleportation will always work from k minus 1, right? So k minus 1 is already calculated. Forget about that. So, but with with k teleportation, yeah. So k teleportation you will calculate it in this manner. Yep, I think would work. So, uh, int n is equal to v dot size, and int n is equal to v dot size. Cool. Yep. And I would go with vector int dpn plus 1 dot n plus 1. Cool. Uh, yep. And dp00, no, dp00 would have a cost of what, 1, 0. Yep. Then let's start from teleportation, 0 teleportations to k teleportations, and each is from, well, you can teleport from such that um, grid x, such that grid x less than, such that grid, okay, so you can teleport from the same place. I less than n, I plus plus, j is equal to 0, j less than n, j plus plus. And then if I is equal to 0 and j, You can continue maybe, right? Because I think it will always be, yeah. Now, mm, so basically what we will say is that there are two possible ways. That is, you can teleport from any index from the previous slot, and let me call it X. So first of all, see, if X greater than 0, then DP, it's going to be a 3D DP. I won't go for array. I don't really like them. So first iteration, first one would be vector int. Okay, so n plus 1. Okay, let's have third one as k. Maybe I need first one as k, right? Second one would be n. And here I can have uh, vector int m plus 1. Cool, looks fine to me. So yeah, so then what we are calculating txy, right? So int and answer is equal to dp txy. Cool. Now you can work with answer. So uh, let's call them infinite. ll ll. Um, yeah. So answer is equal to min answer dp x minus 1 y, and teleportation would be same k, and plus what, vxy. Yep, vxy, right? Same I can do for column. If your column is greater than 0, then x would be same and y minus 1. Yep, that's it. And then we can iterate on all is equal to 0, I less than y plus plus. This is only possible if t greater than 0. Yeah. So if t greater than 0, then what we are basically doing is that if v if vij greater than equal to vxy, right, then what we can say is that answer is equal to min answer dp t minus 1 ij. Yeah, that's it, I think. It should be t, it should be t. Here it should, yeah. So Vij should be minimum of t minus 1 ij. Cool, because there you can come cost free. So I think that's it. Our DP is more or less done. Now, what I can call for any thing, any k would work. So for int t is equal to 0, t less than k, t plus plus, t is equal to k, t plus plus. Res, let's call it LL res equal to 180. Minus 1 is not in the picture, right? I mean, of course, you will always reach. So, uh, it is n plus n minus 1 is the way, right? Like, is it that? Like, Uh, I don't know, maybe m plus m plus 100. Who cares? Okay. So no, cost. There's cost attached. So let's call it 1e18. Why do bother about it? So res, it could be min res dp t. All t would work, but xy should be in -1 and -1. And then I can just say return this result for me. And let's see, we'll have some compile time errors. Yep, dp00, dp00 is equal to 0. I think all dp would be 0 only. So if x is equal to 0, then you can say dpt dpt x y is equal to 0. That's because it's gonna be 0. Uh, can okay, so let's call it ln. Runtime error heap overflow. Cool. So first of all, we go to k plus 1. We go to n. First dimension is k plus 1 indeed. Uh, okay, here it happened. Cool. Okay, this will be m. And yeah, I think there it's fine. Finally, we have some answer 0 and 0. Fine, let me see about it. Yeah, of course, we don't have 1e18 here. If we had, it won't be the case. 7, yep. 9, is it 9? It is 9. So now the last thing, that change everything to LL, because why to take risk? 7, 9, and I hope so it works. Time limit exceeded? Really? Wait, let me analyze it. So this is 10. This is 10 into 18 to 80, not an issue. Then you have 10 into 18 to 80, and then you have well, how is it a TLE? I don't. I mean, see, it's this is 18 to 80, right? This is 18 to 80. This is uh, maybe could be 80 to the power 4 into 10. Where is so 4, 4, 8, 9? Okay. Let me get rid of LL for the sake of it. 10 to the power 4. Okay, so we don't need LL at all. I think 1e9 would do. 1e9 would do. And wherever you have LL, not this one, but from here, can you replace with int? Yep, here I would go with int. 1e9, we are not crossing, right? Because the whole sum would give me, we are not crossing 1e9. We are not. But, I mean, TLE, let's see. Arrays are faster, although. If it's again a TLE, then I would, of course, see something else. Okay. So it's a close call. How can I optimize it? Cool. Let me think about it. How many numbers do we have actually here? Wait, we have 10 to the power 4 numbers. For each number, we can store. Let me think about it. So basically, what is the problem that we are iterating on this whole thing for the previous index? What I just need is the minimum values from nodes that are smaller than this. Yeah. So, well, whatever uh, these would have as their answers. Well, see, these nodes can be pushed in a sorted order, right? Yep. These nodes can be pushed in a sorted order. Cool. That's fine. Now, somewhere there would be my node. These are all of the nodes that I can take. So on these, I can make a prefix sum. Cool. Would do. So I need to provide IDs to each number. How can we do that? We can do that like this. So let's call it vector tuple int v, and let me take a loop from here. This is the one. Okay. So what basically I'm needing here is uh, I just need this loop, nothing else. Now I'm gonna push v dot push back. First of all, Vij and then Ij. Cool. This would do. Yep. Then we can sort it. Sort v dot begin, v dot end, and then I can have a vector int id n, vector int m, and for int I is equal to 0, I less than v dot size I plus plus. We can assign these IDs to these guys. So auto ID, let's call it J. No, ID is with us. We just need val xy is equal to vi, and then I can just say id of xy is I, right? That's cool. So now I will have these IDs. Cool. Then I can maintain a prefix uh, sum, right? Because all of these will have the minimum answer for them. Okay. So vector int pf v dot size plus 2, maybe, I don't care. Yep. And then whenever you find an answer, right? Whenever you find an answer, this is one answer that uh, continue, right? So whenever you find an answer, what you do? In index is equal to id xy, right? This is the id. And in pf, you will do pf int is equal to dp dxy. Cool. That's what we're gonna do. Same thing here. Where are this we don't need anymore. So I mean this we don't need this thing. So after this we will be done with yeah. So I think here we can say PF. Uh, Here we will be done with whatever it is. So I can say int is equal to id xy, and when you have this id, you can say pfind is equal to uh, whatever this answer was. Cool. Now this pf will get updated after each teleportation, which is after this loop, right? This is for y, this is for x, and this is for this loop. What this is for, I don't know. I think we don't need this one. Yep. Yeah, now it's one. So yeah. So now what basically we can say that after this thing, we will update this. So what we just need to do is for I int is equal to 1, uh, I less than pf dot size I plus plus, pf I is equal to min uh, pf I minus 1. Cool. Now what if this thing is true, right? In starting, I think you can initialize it with whatever, maybe 1e9. And if this is true, then basically I think 1e8 would be better. So if this thing is true, right? This thing is true where we were uh, here. So if this thing is true, then what I can say is that answer is equal to min answer. What I need to find the ID. So in is equal to in xy. This is his ID, right? So if uh, this if int is greater than 0, well, you can come back from this also, right? So it doesn't matter. You can come back from here only. So what I can just say is that you can take pf in. Yeah. So first of all, I think this first of all we need to see the uh, redefinition of v. Okay, we need to call it some, we call it vv, and we use vv, no, vv, vv, vv. Anywhere else are we using vv, 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 id. Okay. 0 and 0. Let me think about it. Some might be some issue with prefix. So what we are basically doing is we are, let me name it something else. So I will name it ARR. So this is ARR getting its values, then ARR is getting sorted, then this is ARR, and every value in ARR, this is also ARR, then every value in ARR is getting its ID. Cool. Fine till now. Then you're creating a prefix of same size, I would say. Why to create a bigger one? Cool. I think till this point it's all fine. Mm, yep. Now basically, uh, yes, unit. If x greater than 0, then maybe. So PS is getting modified, but I got it. So PF updation should happen in the new one, right? So for each one, I have to create new PF. Attend in PF AR dot size 1e9, right? Yep. And updations should happen at npf. Yeah. And after this, we can say pf is equal to npf. Yeah. 2. Okay, that's wrong again. But let me actually output IDs maybe. Where are we actually doing it wrong? So see, first of all, everything goes into our ARR. It gets sorted on the basis of value. Yep. And everybody gets their ID. Yeah. Okay. Then you initialize a prefix. Okay. Then you go inside, you inside new prefix. Then you start iterating. Int and answer HTTPX. If x is 0 and y is 0, you will be always able to get there in 0 moves, right? Yeah. So that's 0. And continue, right? X greater than 0, then answer is equal to min. This thing is fine. This is not bad. If t is greater than 0, then you can take minimum of any of these. That is somehow causing these problems. Zero, that's weird. Okay, it's I think ID is not working. Mm, Let me take a loop and see out everybody's ID. So 0, 1, 2, 3, 4. ID is fine, okay. But see, is it due to 2 is causing some kind of error? It is always 2. Why? That's the whole issue. 3. From 0, uh, I mean, we need to reach 5, right? And move down 0 to 2 to say 5 is 7. You can teleport at most k times. Need to once you can't teleport anywhere. Oh man, you can just, this is going to be a suffix, not a prefix. So maybe I can just reverse sort them, right? Yep. 11. That's bad. So see, reverse sort, what reverse sort did was that mm, in reverse sort, hey, five can take from other five. That's the whole point. Hmm. Okay. So why not go value wise? Yep. Well, how can I remove duplicates? That's the whole issue. Well, see, what we are storing at the t minus 1 from this value, what would be the minimum case? So why not make a value map? But value map is 1e4. 1e4 is bad. No, 1e4 is not bad because it's 1e4 into 1e4 is not bad. 1e4 is not bad, so we can let me comment out some stuff right now. So let me comment this out. Uh, let's call it. Mm, mm, as NPF would be let's I've done it faster, but okay. Uh, what answer? 7 and 9. It's 7 and 9. Okay. So we got rid of most stuff. PF, see, PF and PF happen just 10 times, right? It's 10, right? Mostly. They are happening just 10 times. That's it. Okay. The idea is same. Wrong answer. Why? I mean, how it could be wrong? There are no duplicates. Still wrong. Expected for. Okay. I think about it. If t greater than 0, answer is still true. PFE. PS star. He say you can go to 1 and 1 say you can go to 4. Yeah. So, well, we are doing it wrong. देखो 3 को 0 किया होगा तो 3 पे वैल्यू 0 रही होगी, राइट? टूल इसको 1 बनाया होगा, इसको 10 बनाया होगा, राइट? देन वही वैल्यू भी रही होगी वहाँ पे. अब सी व्हाट द थिंग इज दैट the one teleportation to रहे हो तो 4 cannot make use of 1. No, 3 can use of 1. So 1 teleportation से 1 पे जा रहे हो. So you can make use of 3 at 0 teleportation. So 3 at 0 teleportation should give you 0. So they should give you 0 here. Is it not giving? Uh, after each T I need PF basically. So why 0 is not 0? That's the, oh, why 3 is not 0? PF, man. PF. 4. Small issue. I've done much earlier if didn't underestimated things, but still not a bad. Could have been a better performance, but yeah, I'm kind of disappointed. I mean, I should have actually thought about so 380 AKs. Then I think I must be um about 500 or some. No, not 500, of course. I mean, I don't know, just